Our next talk is by Joe Smith, talking more about sage-grouse, only getting into the microhabitat specialist or generalist. Joe?
Thank you. I just wanted to start off by acknowledging my co-authors on here. I think in the program it just says Joe Smith under there, and I want to dispel any notion that this is a one-man show. So if you love it, spread the love. If you hate it, I'm happy to share the pain. So we've been studying sage-grouse for a long time now, studying sage-grouse habitat for a long time now, and for most, I'd say the vast majority of that time, studying sage-grouse habitat has looked like this, what you see these people doing in these pictures. It involves going to a place where we know an individual sage-grouse was found at one point, whether that's, for example, a nest site, stretching out a couple of meter tapes and taking our Daubenmeier frames, our meter sticks, our Robel poles, and gathering very detailed data about the composition of plant functional groups and their structure, things like height and percent cover. So there's a very rich literature out there about sort of this microhabitat. This is just a smattering of papers that actually have the term microhabitat in the title, but there's hundreds of papers that are looking at habitat at this particular scale. So it should come as no surprise that when management guidelines for sage-grouse were developed about 20 years ago now, they reflected this fairly narrow perspective in terms of scale of how we look at habitat. So anybody who's done any work with sage-grouse or even sagebrush ecosystems is probably familiar with this table on the top here. This is from what are generally called the Connolly guidelines. So what they did was they took every available study and kind of tried to summarize what habitat looked like, what high quality habitat looked like for various seasonal habitats for sage-grouse. And they came up with these numbers. And this is, even though this is almost 20 years old now, these Connolly guidelines very much live on today. So they were adopted in a lot of cases with almost no changes into documents that guide management of public lands, such as the Habitat Assessment Framework, Table 2.2 from some of the recent BLM land use plan revisions. So this is a very influential set of guidelines that we're still following. But I would argue that there's a problem with this, and a lot of the problem stems from the fact that there's a big scale mismatch between what the science tells us about and what managers want to know. So these microhabitat plots, and this is on the log scale, so this is the disparity is even larger than it looks on this. But microhabitat plots typically range from a few meters to maybe 100 meters on either side of a place that was actually used by a sage-grouse. So say a sage-grouse nest, for example. Managers, though, are dealing with areas like pastures or ranches or entire BLM allotments. So these are much, much bigger areas. And it's in ecology, almost everything, relationships are almost all scale dependent. That's a very common property. So we don't necessarily know that patterns that we document at these microhabitat scales can scale up to scales at which managers are dealing with. So when I was a young, eager graduate student just getting started, I went to the literature like you do, and one of the most common patterns for sage-grouse nesting habitat ecology is this positive relationship between the height of grasses and nest success. So a lot of studies have documented this. Where you tend to have taller grass, you tend to have higher nest success. But again, at this scale of right around the nest. And so a lot of people have taken that information and sort of inferred that, well, that could mean something about impacts of grazing or opportunities for grazing management to affect nest success, which is an important vital rate for sage grouse. The idea here is, of course, if cattle are eating that grass and forbs, this herbaceous material, they're reducing its height. They could be reducing hiding cover and thus increasing predation rates on nests. But this had actually never been tested. This was just sort of an assumed consequence of this positive relationship with grass height. So what we did is we set out to actually test that at management scales. When I started, there was a large effort in central Montana as part of the Sage-grouse initiative under Working Lands for Wildlife to improve grazing management, to try to implement these grazing practices that were specifically designed for sage-grouse to increase that hiding cover and thereby increase nest success. So in a one area of high abundance in central Montana, about an hour north of Billings, we started up a project where we had 10 landowners enrolled in these Sage-grouse initiative grazing systems. And I won't go into too many details on what those grazing systems looked like, but generally we're talking about rotational grazing management that incorporates a period of rest. So this was kind of the rest period was sort of supposed to be the secret weapon of these grazing systems. On an annually rotating basis, most of these ranchers elected to incorporate a period of rest that would include 20% of the identified nesting habitat on their ranch. So every year on a rotating basis, 20% would have no grazing, and that would last for 15 months to include 2 sage-grouse nesting seasons. So the idea is those rest periods will allow that grass to be taller and thereby provide that hiding cover, increase nest success. And so we tested this. And on the one hand, the left-hand chart here is showing that we found some evidence for that micro scale pattern that I mentioned, where taller grass was associated with higher nest success. And in our case, we found a relationship with residual grass height. It was weak, but in the expected direction. However, that didn't scale up to management. So on the right side, this is showing nests based on whether they were in a pasture that was not enrolled in SGI grazing systems versus ones that were enrolled in SGI grazing systems but grazed that year, or ones that were in that period of rest. And overall, these grazing systems did not have much of an impact on nest success at all. But the interesting thing was that comparison between the grazed and the rested pastures. We actually found that nest success was lower in those pastures that were being rested, which is completely the opposite expectation of what you would think if this relationship on the left here scaled up. So replication is kind of the hallmark of science. It's easy to sort of dismiss something as a one-off if it's not replicated, but there's a parallel grazing study, a very large grazing study going on in Idaho at the same time that we were working out there in central Montana. And they are actually finding shockingly parallel results. So they're finding that even though there's positive relationships between the height of certain species of grasses and nest success that were highly significant, they are actually finding significantly higher nest survival in grazed pastures as opposed to those that weren't grazed that year. So these results were interesting, unexpected, and also got us thinking just about, in general, all of these other guidelines that we follow. What's the possibility that some of these other guidelines don't scale up to management scales? So what we did is we conducted a meta-analysis on every available study we could find that reported at least one of these variables, these vegetation metrics, at nest sites and random sites. And we also looked at we pulled out information on means and standard errors of those variables, and then we also pulled out estimates of nest success from all those studies. So we've got pretty good coverage. A lot of people have studied sage-grouse nesting ecology, it turns out, all over the range. So we had over 40 studies, a ton of data that covered a pretty good spatial coverage of the range of sage-grouse. So the first thing we wanted to look at was just habitat use, habitat selection. And an easy way of kind of looking at this is comparing availability on that x-axis to what they're actually using. So you look at what's the average, say, percent cover of shrubs out there on the landscape, and then what's the average percent cover of shrubs in a place where a sage-grouse nest was found. And if they're a habitat specialist, what you'd expect is that regardless of variation in availability, they're going to be selecting a pretty narrow range of that variable at their nest sites, right? That's what a habitat specialist would look like. And it turns out sage-grouse don't really look like that for anything that we looked at, for any of these variables that are commonly measured and reported. There's some selection going on for certain, especially for shrub cover and shrub height, but they're essentially using places that are a little bit shrubbier than average, but look almost identical to the surrounding habitat, no matter where they are. So this was sort of our first, maybe these guidelines aren't perfect, but this is, again, just habitat use, and occurrence isn't everything, right? We want to know if there's difference in habitat quality along some of these gradients too, because it doesn't just matter where they are, it matters how they're doing. So that's where those estimates of nest success came in. So if these guidelines are useful, what we'd expect is that as you checked off more of these boxes, we've achieved, say, sagebrush cover of 15 to 25%, shrub height of 12 to 30 inches. As we check off more and more of these boxes, we should see, on average, that nest success is increasing. However, that's not actually the real data. This is what the data actually look like. We find no evidence that meeting these guidelines has any predictive ability to predict nest success. Another interesting finding from this was that these guidelines are essentially unachievable most places. So what you're looking at here are the distributions of what nesting habitat actually look like across all these studies. So these are actual measured nest sites compared to the guidelines, the Connolly guidelines, which are shown in these gray shaded areas. And it turns out more than 90% of places we've studied sage-grouse don't meet all these guidelines. So I would argue that we have a bit of a precision problem with sage-grouse habitat management. And this isn't the first time this sort of thing has happened. This paper, which came out a handful of years ago, I think in 2006, called The Precision Problem in Conservation and Restoration, points out that this is a problem in a lot of different systems. These authors basically argue that there's sort of an inherent, we have this inherent desire to try to strive for precise management targets. It gives us kind of the warm fuzzies, and but they argue that there's not only are these precise management targets oftentimes unfounded and unnecessary and also expensive, but they can actually have unintended negative consequences. And a lot of that stems from the fact that, and they lay this out pretty nicely in this paper, and I definitely recommend looking this up. But heterogeneity is, we know, critical for resiliency of systems. And precise management targets are essentially fighting heterogeneity. That's what precise management targets do. So I think if we're not reevaluating how we assess and measure quality for sage-grouse habitat, we're going down the road of becoming sort of another textbook example of precision, what they call precisionism. So it's easy to criticize. It's not so easy to provide constructive alternatives, but I would say a place we can start is just by embracing the natural heterogeneity of these systems. So this is 4 pictures of sage-grouse nesting habitat from totally different corners of their range. But there's a sage-grouse nest in every single one of these pictures. And not only that, but these are from studies that were part of our meta-analysis, and I know that sage-grouse nest success was similar in all 4 of these places. So if there's anything that these 4 pictures have in common, I think it's that, these are sagebrush dominated native vegetation without a whole lot of anthropogenic fragmentation. But there isn't a single set of sort of one-size-fits-all vegetation management guidelines that are going to work for all of these places. And I'll just close with this, which really doesn't require any explanation. I think the picture says more than I could possibly convey in words. But I think we've moved past a point where these sort of plot level perspective of looking at habitat is constructive, and I think the threats that face sagebrush ecosystems are operating at much larger scales, and we're going to need kind of a new set of tools and to open up and broaden our perspective to deal with those. And with that, I'd be happy to take any questions. I think I have a couple minutes. Thank you. Yeah.
I guess I'm curious to address your title. Do you have any perspective on where you draw or where you put sage-grouse on that spectrum of generalist to specialist?
Yeah, great question. So if anybody didn't hear that, he was just going back to my title, which is our sage-grouse a microhabitat specialist or a generalist, and what's my take on that? And yeah, I didn't really circle back around to that, and that's more of a it's more to provoke thought than take a particular position on that. But I do think I would argue that they're more of a generalist than we've been giving them credit for. Yeah. Yes.
So, Joe, were your results regarding the effects of different grazing systems consistent across grains and stocking density?
So the question was, were our results about the grazing systems consistent across a gradient and stocking density? That's stocking rate is not basically for the ranches that weren't enrolled in SGI grazing systems. We weren't able to get that data. We don't know what stocking density was, but so that there was really no sense in comparing SGI to non-SGI in terms of stocking rate if we didn't have that comparison. But that's not. It's also such a localized area that people aren't doing dramatically different things in terms of stocking rate for the most part. There's a couple of people who are using sort of higher intensity, short duration grazing, but we didn't actually have any birds using that area. So yeah, I don't have a great answer for you there, but.
Just a comment, we have found almost the exact same thing for sharp-tailed grouse, eastern montana, mixed grass prairie, relative to that same rust rotation grazing system as you get for sage-grouse.
Oh, interesting.
You'll get gradients in stocking rate, thinking that mediates the effects of the conservation value of the rust rotation system.
Sure.
Up to
Still no difference.
But stock rates are relatively moderate throughout eastern Montana, including around the area.
Yeah, I would agree with that. I would agree that in most cases people are grazing very conservatively regardless of what system they're using. Yeah.
Thanks,
All
Joe.
right. Thank you.